So at the tail end of the last video, I started with number 6 on 5.2, and all I did is algebra up until this point. So what I noticed was that the numerator is bigger than the denominator, so I used long division to rewrite it. So this is the same thing in like a mixed number format, okay? So I know how to integrate 2x. What is the integral of 2x? It is 2x squared over 2, so I get x squared. What's the integral of 17? It is 17x. And then remember, for this part, I can rewrite that as 97 times the integral of 1 over x minus 6 dx. So the 97 is coming along for the ride. And then is the derivative of the bottom and the top? Yes, it is. So that becomes 97 times the natural log of x minus 6 in absolute values plus c. So again, I just rewrote that using long division, and then it became something that was integrable. I was allowed to integrate it. All right, so I'm going to come back to number 7. I'm going to bounce to the end. So I know I'm kind of all over the place, but this is number 15. Number 15 says that I need to restrict where I'm integrating from an x equals 1, an x equals 4, and y equals 0. You can't see. All right, so y equals 0 just means I'm going to chop off everything underneath the x-axis. That means my limits of integration are from 1 to 4. And then my integrand is x squared plus 6 over x. So what I have is from 1 to 4 of x squared plus 6 over x dx. And when I first glanced at it, I was like, oh, we're going to have to do substitution. No, we're not. Because this is 2 terms over 1 term, which means this denominator belongs to each one of those. Okay? So when I rewrite this, I'm going to get an x plus a 6 over x. So I'm going to integrate this from 1 to 4 of x squared over x becomes x plus 6 over x becomes 6 over x dx. And now it's integrable. Okay, so the integral of x is x squared over 2 plus, remember I can rewrite that as 6 times the integral of 1 over x dx. And the derivative of the bottom is in the top, so the answer is the natural log of the bottom. And since this is a definite integral, or the limits of integration are defined, I'm going to evaluate with a 4 and then evaluate with a 1. So if I shove in a 4, 4 squared over 2 is 16 over 2, which is 8, plus 6 times the natural log of 4. And since 4 is positive, you don't need absolute values anymore. And then minus, well, if you notice when you shove in a 1, this part's going to go to 0, but don't fall for that because this part won't, okay? So I've got minus 1 squared over 2 is a half, and then plus 6 times 0. So I just need to subtract a half off. So 8 minus a half is going to be 16 halves minus 1 half is 15 halves, plus, dadgummit, hang on. 15 halves plus 6 times the natural log of 4. And that's that one. All right, so the next ones, I'm getting a new piece of paper. Actually, I'm not. All right, I call it, because I'm weird, I call it scary U substitution. And it's not scary. The official word is substitution by exchanging variables. Okay, it just means we're going to go a little bit further and deeper into U substitution. So the first thing you want to do is do what we've done with U substitution before. So that means identify your U. So identify what U is. And for the scary U substitution ones, we're usually going to tell you what U is until you get the hang of it. Once you identify U, I want you to solve it for X. Okay? So then rewrite it so that instead of a U equals, you're going to have an X equals. So solve for x, and then you're going to take a derivative of both sides. And then we're going to use some back substitution to rewrite this stuff. So basically, instead of having when we take the derivative, it's not going to be so obvious what's going on. So why don't I just show you an example? Hang on, I got to find it. All right. So I'm going to do 8 and 9, and then I'll round up with 7 because 7 is not U substitution. All right, so I've got number 8 says I've got the integral of 1 over 9 plus the square root of 2x dx. And the first thing I notice is that the derivative of the bottom is absolutely nowhere in the top. Okay, I can't separate this out to a 1 over 9 and a 1 over root 2x because that's backwards. Okay, I can't have, my common denominator is 9 plus 2x, okay, root 2x. All right, so what is our strategy? Let's go ahead and dive in, and if you'll notice in the instructions, it says, hang on, where are the instructions? It says let u be the denominator of your integrand. So again, we're going to tell you which one it is at first. So that means my u is going to be a 9 plus root 2x. Okay, that's my u. So according to my strategy here, I've identified my u, and now I'm going to solve for x. So instead of me, because look what happens. If I take the derivative, this thing is going to be 1/2 of 2x raised to the negative 1/2 times 2, which just makes everything messier. So I'm creating something that is nowhere near being in this thing. Okay, so my, what did I just say? I'm going to solve for x. So that means I'm going to subtract 9 from both sides. So I get root 2x, and now I'm going to square both sides. Okay, so I've got u minus 9 squared equals 2x. And now I'm going to divide both sides by 2. Okay, so what did I do? I identified my u, then I solved for x. So take this and get x by itself. And now that I've got x by itself, take a derivative of both sides. So I'm going to drop this 2 out front, which is going to reduce with my denominator. So this simply becomes u minus 9 du equals 1 dx. So when I do this, what I'm going to do is I'm going to take bits and pieces, and I'm going to substitute into this thing. So I need 1 dx. Okay, I need one of the dx's. So do I know what dx is? I do. So when I resubstitute, my dx with one of them is going to become u minus 9 du. So he is u minus 9 du over, well, now I need this portion. Well, what is this portion equal to? That portion is equal to my u. Okay, so this is just u. So this thing and this thing are equivalent to one another based on the substitution that I did. They look totally different, but they're essentially the same. So now we're back where I was on the last problem, and I can separate this thing out this way. So this becomes u over u is 1 minus 9 over u du. So remember, you are in u world, not x world. So what's the integral of 1 du? It is u minus, remember this is 9 times 1 over u. So that becomes 9 times the natural log of u plus c. Well, you started in x world, so you better end in x world. What's your u? Your u is 9 plus the square root of 2x minus 9 times the absolute value of u, which is 9 plus the square root of 2x plus c. Okay, so basically you got to fight your way through it and figure out, because at this point you know how to do power rule, you know how to do different trig substitutions, you know how to do if the derivative of the bottom is in the top. So you know these little tricks and that type of thing. But you're going to end up slamming your head in a brick wall sometimes. So that's where we end up going to here. All right, so let's do another one. I've got the square root of x over the square root of x minus 6. Okay, so the square root of x over the square root of x minus 6 dx. So the derivative of the bottom is not in the top, so I'm stuck there. And so basically it's going to tell us to do some u substitution. So it flat out tells you, let u be the denominator again. So step 1 is identify your u. So u equals the square root of x minus 6. Step 2, and here's where you would make the difference, because if I take the derivative, it's going to be 1/2 x to the negative 1/2, which is not what I have. And I can't balance to get it. So that's where you would make the decision to swap variables. All right, so I'm going to solve for x. So that means I'm going to add 6 to both sides. Then I'm going to square both sides. And now I'm going to take a derivative. Okay, so that gives me 2u plus 6 equals dx. And I forgot my du. Sorry. All right. So I took the derivative of both sides. And now I'm just going to back up and see what's going on. All right. So what do I need? On the last one, all I had was a 1 dx. Well, on this one, I've got the square root of x. Do I know what the square root of x can be replaced with? I do. It can be replaced with u plus 6. So I've got a u plus 6. I have a dx. Can I swap that out? Well, instead of a dx, what can I put? I can put 2u plus 6 du. So 2u plus 6 du over, and then can I rewrite the square root of x minus 6? Well, what is the square root of x minus 6? The square root of x minus 6 is u. Okay, so I am going to move this thing along. What do I have? I've got a 2 that I'm going to pull out front. So there's my 2. So this is taken care of. I am now going to FOIL this part out because this is a u plus 6 times a u plus 6. So that gives me u squared plus 12u plus 36 over u du. And now I can reduce like I did on the last one. So a u squared over 2 becomes u. A 12u over u becomes 12 plus a 36 over u. And now I know how to integrate. So the integral of u, remember 2 is coming along for the right. So the integral of u is u squared over 2 plus the integral of 12 is 12u plus, remember this is 36 times 1 over u. So that becomes natural log of u plus c. And now I can back substitute. So instead of a u squared over 2, I'm going to have a root x minus 6 over 2. So I'm running out of room. Here, we're going to write sideways. All right, so I've got a 2 times, instead of u squared over 2, I'm going to put a square root of x minus 6 over 2. And that's squared, okay? So this thing squared. Plus 12 u's, which is the square root of x minus 6, plus 36 times the natural log of u, which is the square root of x minus 6, plus c. Okay, so it's scary, but that's what you do. So that leaves us with one more problem to do, and this one just gets a little bit more exciting. It's no big deal. All right, so what do I have? I have 2 minutes. I don't know if I can get this done in 2 minutes. All right, so the problem is 3x over x minus 6 squared dx, okay? So I'm going to do, and this is a new strategy. You would not know to do this off the top of your head. So you're learning strategies. I'm going to pull that 3 out front, so remember the 3 belongs to everything I do. And when I do that, I'm going to go ahead and FOIL this thing out on the bottom. So this is a new strategy that you probably would not know how to do otherwise. So this becomes x squared minus 12x plus 36 dx, okay? So one of the things I notice is that the derivative of the bottom is 2x minus 12. Well, I have an x, okay? Can I make a minus 12? I can. So I am going to multiply by 2 and divide by 2. Okay, and now what I'm going to do is subtract by 12 and add 12. Really and truly, you've only added 0. Okay, so I balanced with my 2 out front, but over here, I've really only added 0. So now I'm going to separate this out. So 3/2 belongs to everything I do. So I have a 2x minus 12 over an x squared minus 12x plus 36 dx. And then plus, notice I didn't incorporate this part. I've got a 3/2 and then 12 over, and now I'm going to go ahead and rewrite this thing. So it's an x minus 6 squared dx. So these two things got paired up with this denominator, and this one got paired up with the same denominator. I just rewrote it. So why did I do that? Because now I got the derivative of the bottom and the top, which means this is 3/2 times the natural log of x squared minus 12x plus 36 plus 3/2. This thing is actually just 12 times x minus 6 to the negative 2. So that becomes minus 12 x minus 6 to the negative 1 plus c. Sorry that was messy, but I have 6 seconds left. And I finished.